Welcome back to The Explainer. Today, we're diving into an absolutely fascinating challenge in quantitative finance. We're going to do a comprehensive overview of a late 2025 research paper by Andres Garcia Medina titled Denoising Complex Covariance Matrices. At its core, this is a story about using a brilliant hybrid AI approach to tame incredibly volatile, high-dimensional data within the cryptocurrency markets. Okay, let's dive right into this. Here's our roadmap for today. First, we'll look at the crypto data problem. Second, a hybrid AI solution. Third, surviving the bear market. And finally, beyond just cryptocurrency. So you really have to ask yourself, how do you find stable patterns in the completely chaotic world of crypto? I mean, this is literally the ultimate challenge for financial data analysts out there. When markets are highly unpredictable and shifting wildly from day to day, trying to isolate which assets actually move together and determining true underlying correlations is remarkably difficult. There is just an overwhelming amount of market static. Section 1. The crypto data problem, focusing on market volatility. Now, to understand what's going wrong, we need to talk about covariance matrices. Think of a covariance matrix as a mathematical relationship map. It tracks how different assets move together over time. But here's the massive problem in crypto. These relationships are built on data that's incredibly short, extremely noisy, and notoriously non-Gaussian. Because of these huge deviations from normal distributions, empirical correlation matrices become highly unstable. You could estimate a covariance matrix today, and tomorrow, well, the entire eigenvalue spectrum has completely shifted just because of the underlying market noise. To really get to the bottom of this, Garcia Medina analyzed empirical evidence from exactly 89 different cryptocurrencies. And the results? They revealed these deep, hidden structures. We're talking about complex power law scaling and profound hierarchical interactions. So, rather than acting as independent, random variables, these tokens are actually bound by structural dependencies. The catch is that standard analytical tools completely fail to capture these connections amid the daily price fluctuations. Moving on to Section 2, a hybrid AI solution, or the dual-wielding framework. And this brilliantly illustrates exactly how Garcia Medina solves the problem. He introduces a two-step framework. On one side, you have random matrix theory, or RMT. Think of RMT as a heavy-duty mathematical filter that regularizes the eigenvalue spectrum to strip away all that high-dimensional random noise. But filtering alone just isn't enough. So on the other side, a residual neural network, or ResNet, steps in. While RMT cleans the surface eigenvalues, the ResNet acts like an AI detective. It learns data-driven corrections to recover the latent structural dependencies hidden deep within the eigenvectors. So the process is a two-step hybrid estimator. Step 1, hierarchical filtering using random matrix theory to isolate the true signal from the bulk noise. Step 2, applying the ResNet data-driven corrections to map the actual structural relationships hiding underneath. And the proof is in the math. Through rigorous Monte Carlo simulations, Garcia Medina proved that this exact sequence consistently minimizes both Frobenius and minimum variance losses across a whole array of complex population models. All right. Section 3, surviving the bear market, which was the ultimate stress test. Theory is great, but how does it actually perform? The empirical testing period started in 2020. And this is crucial. Training for the hybrid AI model ended strategically in November 2021. That was the local Bitcoin peak, capturing a period of maximum market euphoria. From there, the model's out-of-sample predictions were tested from 2022 all the way through 2025. They literally threw the hybrid system directly into the fire of a severe bear market crash and the grinding recovery that followed. It was the ultimate real-world stress test. When compared to traditional estimation methods, the two-step hybrid estimator absolutely crushed it. It produced the most profitable portfolios during that brutal macroeconomic period. But beyond just sheer returns, it maintained a highly optimized, well-balanced asset distribution, which shows incredibly intelligent risk management. And most critically, the framework remained robust across severe market regime shifts. It kept its structural integrity even when the market abruptly slammed from a high-liquidity bull environment straight into a restrictive bear market. Which brings us to Section 4, beyond just cryptocurrency, looking at high-dimensional systems. Because this framework successfully addresses what mathematicians call low-rank deformations of Wishart ensembles, its applications go way, way beyond digital assets. It can actually decode hidden hierarchical structures in practically any high-dimensional system that's burdened by overwhelming data and complex interactions, whether we're talking about advanced primate modeling, population genetics, or even mapping neural pathways in the human brain. This hybrid estimator offers an entirely new paradigm for uncovering structural truths in really noisy environments. So this leaves us with a pretty massive question. If this AI math hybrid can successfully decode the absolute chaos of the cryptocurrency market, what other complex systems in our world is it going to untangle next? It turns out the quantitative tools developed to survive extreme financial volatility might just be the exact same tools we need to solve some of our most dense scientific mysteries. Thank you so much for joining me for this explainer, and I'll catch you next time.